There is another strategy for handling collisions. We call it open addressing. With this approach, we don't store values in linked lists. We store them directly in array cells or slots. Let's see this in action. Just like the previous video, let's say we have a hash table with 5 slots, and we want to store this key value pair. Since the key is 6, our hash function is going to return 1, so we should store this key value pair at the slot with index 1. Next, we're going to store this other key value pair. Similarly, this pair is going to get stored at the slot with index 3. Easy peasy. Now, what about this other key value pair? If we pass this key to our hash function, we'll get 1, but there is already an item stored in this slot. So we have collision. Now, to solve this, we have to look for another empty slot. This is called probing, which means searching. We have to search for another location. And this is the reason why this approach is called open addressing, because the address of a key value pair is not determined by the hash function. We have to search for another empty slot. Now, we have 3 searching or probing algorithms. The first one, which we're going to talk about in this video, is linear probing. With this algorithm, we start from the current slot. If it's full, we go to the next slot. If it's full, once again, we go forward until we find an empty slot. Now, what if we can't find any empty slots? That means our table is full, and this is one of the drawbacks of using the open addressing strategy. With the chaining strategy, we don't have this problem because our linked lists can grow automatically. So back to the business. In this example, we should store this key value pair at index 2. Here's the formula for linear probing. We start with our hash value and then increment it by 1 at each step. So I here is like a loop variable that starts with 0 and gets incremented until we find an empty slot, okay? Now, because we're incrementing I in every step, it is possible that I ends up being outside the boundary of our array. So we should apply the modulus operator and reduce the result to a range that can fit in the array. Now, there is a problem with this linear probing. These 3 items stored next to each other form a cluster. Next time we want to add a new key value pair, where the key falls in this range, our probing is going to take longer. We have to pass all these items in the cluster and add the new item at the end of the cluster. As a result, our cluster will get bigger, and again, this will make future probings slower. In the next video, we'll look at another probing algorithm that attempts to solve this problem.